All right, this is 3.8b. I'm on page 290. This is the composition of functions. Now, again, you read the book, and to me, it just makes it really complicated. So I'm just going to kind of give you a real fast overview as far as what a composition of functions are, or what that is. Basically, it's putting something like an X in the function machine, it kicks out an answer, and you put it in another function machine, and it'll kick out an answer. So it's kind of like going through the function machine twice. So if we took our function machine and we put an X in here, and it spit out a Y, then we take that Y and put it in this other function machine, and it may spit out a Z. Okay, so the X goes in the function machine, spits out a Y, it goes in, spits out a Z. So that's what the composition of functions basically is. And it has, just like we did with f plus g, f minus g, f times g, f divided by g, the composition of functions is f little circle g. I don't even know what to call that, but a lot of times my students will just say fog. But it's not a zero. It looks like a little degree sign. If you look at the bottom of page 290, it gives you the symbol there. All right. Sometimes, I know at least when I was taking math when I was younger, I had a hard time understanding what that meant. So what I did in order for me to better understand what that fog was or what to do with it, I would write it like this. And the book does that at the bottom of page 290. So it means I take the inner one first, and then I take the outer one second. So if that were the case, if f of x is x plus 5, and g of x is x squared minus 2x, and I'm asked to find f composite g, or fog, that means f g of x. Okay, so what this means is if I look at, where's my arrow? If I look at g of x, and that's what g of x is, I'm going to rewrite that. I'm going to substitute, instead of g of x, I'm going to write x squared minus 2x, because that is g of x. Well, what is my function? My function is this right here for f. So what does that mean? It means that whenever I see an x in my original function, I put that in its place. So instead of putting an x, I put x squared minus 2x. Okay, and I get that, and then I just finish up by taking the parentheses off and get that. Okay, if this were the other way around, g composite f, or goff, that equals this. Okay, so that means that I do g, and I know f of x equals what? This. So now I look at my second one, and whenever I see a variable, I put x plus 5 in its place. And up there it said that variable is squared, and then 2 times that variable. So I get x plus 5, the quantity squared, so I get x squared plus 10x plus 25, minus, distribute, and then I combine, and that's my answer to this composite. All right, let's move on a little bit. I think, yeah, that's as hard as your composites are going to get. As we get further into stuff, they might get a little trickier. In fact, yeah, when you get to the problems in the book, like 39A, they're asking you to find F composite G, and they give you in the parentheses the 5. Well, you're going to put the 5 in for the G. So, well, let's just do that one. So, what did I say, 39? So we have F composite G of 5. And that means F of G of 5. So my f of x is x squared. My g of x is x plus 4. So g of 5 means whenever I see a variable, I put a 5 in there. So that equals 9. Okay? So now instead of g of 5, I have a 9. So that means whenever I see that 9, I'm going to put it in here for x squared. So 81. So F composite G of 5 equals 81. So hopefully that helps you with that. Let's just spend a couple minutes doing piecewise functions, and then we'll be done with this lesson. So a piecewise function is... sometimes we'll have two or more different equations that we're piecing together. That's pretty much what that is. And there's a certain way that a piecewise function looks. So you can always recognize that, and piecewise functions do not go away. You will be using them for a long time. So if x is less than or equal to 0, if x is greater than 0. Okay, so that's example 5. And all they're doing is asking you to graph it. So what they're saying here is the function, the f of x, or basically the y value, if you were to graph this, is going to be -1 if all the x values are less than or equal to 0. So let's put wrong drawing. Let's go ahead and put a graph on here. All right, so it says that my y, or my f of x, is going to be -1 if x is less than or equal to 0. So that means if I made a table, and I had this written like this, and x is less than or equal to 0. So if it's 0, my y is -1. What if my x is -1? It says if my x value is any number, either 0 or less, my y is -1. So it doesn't matter what my x is going to be, my y is -1. And then I can graph that. 0, -1, -1, -1, -2, -1. So I get this line that looks like, looks like that. Okay? But does it look like that? It says only if my x is less than or equal to 0. So these don't work because those are greater than 0. And I have a closed circle here because the answer can be 0. Now let's look. My y value is 1 if x is greater than 0. So again, I'm going to make my table. What if my x is 0? Well, it can't be, right? Because it says it has to be greater. But it can be any number bigger than 0. So what I have to do here is I have to put an open circle here saying it doesn't include x being 0, but it does include all the other numbers. So like 1, 2, 3, and y is 1 if it's any of those numbers. So 1, 2, anytime x is bigger than 0, my y value is going to be 1. So that's what a piecewise function looks like. Basically, two equations, or in this case, inequalities, that are going to be put on the same graph. So that's kind of what that looks like. So let's do a couple of examples here, 2 examples in fact, and then we'll be done. Okay, so for example 6, what we're saying here is that if x is less than -1, we plug that number in here, and that gives us our y value. If x is greater than or equal to -1, we plug that number into this equation. We ignore this one, and that gives us our y value. So let's go ahead and just look at this top one. So if x is less than -1, so let's say x is -2. So if x is -2, -2 minus 1 is -3. So let's go ahead and graph -2, -3. So one of the things we do want to make sure is we start here, but it doesn't have an equal sign there, so we know that at -1, if we put -1 in here, what do we get for our y value? -2. So we know that's our starting point, but it doesn't count it, so we're going to open circle. But we still have to use -1 to find out where we're beginning. If I do -3, put -3 in for here, and I get -4. 1, 2, 3, 1, 2, 3, 4. Okay, so I get a line that looks like this, and it goes on forever. So let's look in blue at this one. If x is greater than or equal to -1. So if x is -1, we put 2 times -1 plus 3 gives us -2, gives us 1. So -1, 1. Okay, so we tried -1. It says that it is greater than or equal, so that means this is a closed circle. So if it's greater than, let's put 2 in here, because that's greater than -1. So 2 times 2 plus 3 gives me 7. So then for this one, I get a line like that. This is a piecewise function. It's 2 equations on the same graph. And if it's asking you to find the domain and the range, it's asking what numbers can x be and what numbers can y be. X is the domain, y is the range. So the possibilities for this one are the domain is the set of real numbers. And I say it's the set of real numbers because we said that x is less than -1 or it's greater than or equal to -1, which means it goes to the left into infinity and it goes to the right into infinity. All the numbers are going to be included because as this goes higher and higher, the x value, it goes further and further this way, although it goes slow. And this one here, this goes further and further into the negative direction as it goes lower. So that domain is a set of real numbers, all the numbers. If there was a break here, if like this one started here and this one started over there, it would not be the set of real numbers because these numbers here would not be part of the graph. But since this is closed here and this is open here, it includes the -1 here, even though it doesn't here, and it means it goes to the right or to the left into infinity. All right, so there is a gap, though, between here and here. So my range is not going to be the set of real numbers. Got a little bit of a difference there. It's going to be all the numbers from -2. Let's do this differently. -2 and -infinity. Okay, and notice I've got this curved here because it does not include -2, but it goes down into infinity. And then it also starts at 1. So I'm going to put a box there. And it goes to positive infinity with the curve. And the book, I think, is wrong because they put a box around the infinity, and it should not be a box. It should be rounded. But that means we start at 1 and we go up into infinity. So it unions because the answer includes both the numbers below -2 and above and including 1, but it does not include the numbers between here. So we have to put a union sign to say that there's a space between this graph and this graph, and that's the range. So the domain from left to right is all real numbers at nonstop, but the range, the y values, there's a break here. So we have to show that break by putting a union sign. Okay, so that is it for 3.8.